All right, this example, we are going to solve sine of 2x minus root 3 over 2 equals 0 on the interval 0 to 2 pi. You need to know how to find the general solution for all answers before you can solve one like this on that interval. If there's no parentheses here, they are implied as being right there around 2x. You can't include the minus root 3 over 2 into that unless it is in parentheses, okay? So you want to keep that in mind. Think of this as being like under a square root sign or inside of parentheses being squared. It's inside of your trig function. So we're going to start solving this like any other problem. I'm going to add root 3 over 2 to both sides. I get sine of 2x. And again, that x could be a theta. It really doesn't matter. Equals positive root 3 over 2. Then I'm going to apply what to both sides in this step? Go ahead, Zareen. What are we going to apply to both sides?
Sine inverse.
Right, we're going to take the inverse sine inverse. Sometimes you'll hear it called arc sine, A-R-C-S-I-N. Same idea. We're there and here. Now, when you find sine inverse or the inverse sine yourself, I always mention how we're going to find all of the answers. Even though this says 0 to 2 pi, there is this like hidden layer of us finding all of them with that general solution. What is the period of sine? How long does it take for sine to repeat itself? What is the period for sine? What is the period? We just wrote it down before. We talked about the circle. Go ahead, KF.
2 pi.
Yes. So really, you're going to have that plus 2 pi n quality to your example. But we're also going to find 2 quadrants as well for this one. We're finding all answers in every possible way. That's gone right over there. 2x equals, there's 2 answers between 0 and 2 pi to get us started. What's one angle in radians that the sine is equal to root 3 over 2? What's one angle in radians on the unit circle where the sine of that angle is equal to root 3 over 2? Sine is y, root 3 over 2 is a lot, and positive, so up. Go ahead, Victoria. What's one of the angles?
Pi over 6.
Up a lot. Pi over 6 is close to the...
Oh, sorry. Oh my God. Pi over 3, sorry.
Pi over 3 is one of them. I'm going to stick this little plus, 2 pi n. I already wrote this once. I'm not going to rewrite it a dozen times. But I also want to do another spot. So that's here in quadrant 1, okay? 2x also could equal, what's the other angle between 0 and 2 pi? We want to account for all of them within one cycle first. What's the other angle where sine is equal to up a lot? Positive root 3 over 2. So here's the one spot. There's another place where we go up a lot. What angle is that? Any day now? Go ahead, Claire.
Is it 2 pi over 3?
It is 2 pi over 3. Good. Plus 2 pi n. That was this one over here, so I'll just kind of note that right over there. Now, if I didn't have this 2, this 2, here, 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 okay? If I didn't have that 2, we'd more or less be kind of done. We could carry on with our lives and we'd be happy to go. What is the 2? We spoke about this a week or so ago. In the world of graphing, how does this 2 inside of a function, a 2 on the inside of your function, how does that, maybe flip back in your notes, how does that impact a graph? What change happens to the original parent function when we multiply by a 2 inside? So go ahead. It looks like only Zareen. Go ahead, Zareen.
A horizontal compression?
Yes. That will take a parent function of sine. Here's sine normally from 0 to 2 pi. We went over how to get these points over here. Those are just quadrantal angles. It's going to be a horizontal compression. Cut everything, squeeze everything in half. closer to the y-axis. That means this whole cycle, you could think of it two ways. You could think this whole cycle will happen between 0 and pi instead, or you could think two of these cycles will happen between 0 and 2 pi. So if before we only had two places where sine was equal to radical 3 over 2 between 0 and 2 pi, how many answers will I have this time? This is 1, the highest point of the graph is at 1, okay? But root 3 over 2 is a little lower, 0.87. How many places, Catherine?
4.
Yeah, I see 4 places now, exactly. All right, I see it 1, 2, 3, and 4. So what do we do from here? Do you need to know all this visual? No, but will it help in some ways? Yes. Keep solving for x. Keep it classic. I don't want to say divide because I already have fractions. What can I multiply everything by to get x isolated? What can I multiply everything by over here to get x alone?
A half.
Right, a half. Thank you, Jason. We're going to multiply everything by 1/2, make my life a little easier here. So x equals pi over what will it be?
Pi over 6.
Thank you. Pi over 6 plus. Now, what I like to do, even though this is 2 pi n over 2 or pi n, I always like to, when I write it with a common denominator because sometimes you have to add it many times. So let's just get the common denominator over with. So half of 2 pi n is pi n, but with a common denominator, we can just call it, do you want to answer a question, Alice?
I was gonna answer.
Go ahead.
6 pi n over 6.
Yeah, so 6 pi over 6n or 6 pi n over 6, whatever way you want to write it. Now we can start listing our answers. I'm going to use set notation, that curly bracket. You might remember seeing that in the past. Remember that n's an integer, so I could subtract. Sometimes you shift also, so you might have an answer before this one. We don't in this time, because if I subtract, I'll get a negative, and we only want 0 to 2 pi. So I have pi over 6. If I add 6 pi over 6, what else will I get as an answer? Anyone? Good, 7 pi over 6. All right, now this one, I'm going to do the same thing. We're going to tack those answers into here. Multiply by a half. I get x equals. Now, just so I keep everything over 6, even though it does reduce a little bit more, I believe, I just want to have a little consistency. It helps you kind of see things in a new way. So, there's my alarm. So we're done in this 30 seconds here. So I'm going to write this as 2 pi over 6. I know it's pi over 3 plus, and I know that that again is pi n. I'm going to still write it as 6 pi over 6n. So another answer I'll have is 2 pi over 6. If I subtract 6, I get negative 4 pi over 6. I don't want that. If I add 6, I also get 8 pi over 6. Now remember, I want 0 to 2 pi. In your head, here's your thought bubble. You are thinking how 2 pi equals 12 pi over 6. So if you start adding and go over 12 pi over 6, you know you're done. So if I kept going, another 6 on here, I'd get 14 pi over 6, too big. If I added here, I'd get 13 pi over 6, too big. So I'm done. I have a finite number of answers between 0 and 2 pi. If we kind of put them on the graph, pi over 6 would be that one over here. 2 pi over 6 would be right next to it. 7 and 8 are these two, here and here. So if you graphed it in Desmos and then you graph the horizontal line rad 3 over 2, this is going to be where they cross. You could list them in order, whatever. Again, I wouldn't reduce for now. I know I always say reduce. This is one time where I'm going to say don't, because when we graph, we're also going to leave this common denominator. It's very helpful to know that we're doing the right thing. Okay, so these two came from one thing together. These two came from another. So for homework, I'm going to ask that you guys try. Oh, well, let me end this recording. So I'm going to stop here. If you follow, thumbs up. If no, thumbs down. All good. And hope it's helpful.